Okay, welcome to the practicals of Introduction to Structured Programming. We were already announced in the lecture and now we are ready to present the practicals to you. Before we start, maybe we want to introduce ourselves. So maybe you want to start.
Yeah, my name is Julia. I'm studying computer science and I'll be doing the streams, and also in the course I'm managing the test run and everything where your assignments get tested. So yeah.
Yeah, and I'm Michi. I'm also studying computer science. I do this course now for the fourth time. And actually it's the first time that we're doing a course in English. So we try our best to do it in a proper way, but maybe there will be some mistakes that we make, so please apologize if we do them. Yeah, okay, so maybe we start directly with the slides. Okay, what are the practicals? Yeah, so this is the question you may ask. What do we do in the practicals? So basically this is something which is in addition to the lecture. So in the lecture you will hear more the theoretical parts, and here in the practicals we want to apply these theoretical things, but we will also discuss other aspects which are theoretical and which are important for you to program, but also mainly in the beginning of the course we will discuss also other concepts that are related to programming. Yeah, as mentioned here and as also probably expected from you, we will also do some live programming where we program some short exercises and that will help you to solve the assignments. Assignments is also the right word. Of course, we will also present the homeworks and assignments, and another large part is of course to answer your questions. Maybe you already watched the chat. Is there already some question?
No, I don't think so.
Okay, fine. Then maybe we continue. The stream schedule, now we have it from 5 to 8, but this only applies now in October. Then we will switch the lecture times of the lecture and the practicals because it makes more sense in the structure. But for now, for this and the next two lectures, it will be from 5 to 6.
Okay, so in the chat you can always ask us questions. Of course, the same as in the lecture, they will be moderated. We will try to answer as many of them as we can, but you will also get the opportunity to ask questions at the end of the stream with Menti. Yeah. So sometimes there will also be quizzes, I think starting next week, but most importantly, it's also for questions at the end of the stream. Yeah.
And where can we find this Menti?
Oh, okay. So I think you have the link in the description.
Yes.
Yeah. There you can open it then, but you can't ask questions there right now. It's just for the end of the stream. Right now, please use the YouTube chat. So our communication for the practicals is primarily on Discord. There you can ask questions, communicate with tutors, and also repost announcements. This is for any type of questions. And also be sure to first look at the Discord if your question is already being answered. Then general information is also on our website and in the especially in the FAQ on our website and in the practical section. Yeah, this is the website. And then we use the Teach Center just for registration for coding sessions and question hours. And then you will have to submit your homework there. Perfect.
Yeah. Okay, so you already said homeworks. So maybe we discussed them. I think it was already mentioned at the beginning of the lecture. The homeworks will be short exercises and there will be 3 of them during the course. And we're happy to announce that the first homework already starts today, and we will discuss the first homework also in today's stream, but at the very end. Yeah, so you have to stay until the end to get the introduction to the first homework. Yeah, we also put you the timeline here, but basically you see that the first homework starts today. You have 2 weeks time to solve it, and then the second homework starts immediately afterwards. And then there is some break until the third homework starts, which will happen in December.
Okay, so let's get to the assignments. Yeah, the assignments are probably way more complex than the homeworks. The homeworks are really just some small exercises, and most of the practicals, the time you spend will probably on the assignments. The first assignment is sent out on the 9th of November. Yeah, and I have some dates here also for the question hours and when you will have to submit the assignments. Also for the second one and for the third one. The third one will have 2 question hours. But yeah, for I won't go through them right now.
Yeah, so you can find every date in the Google spreadsheet that David showed us.
Also, the slides will be online after the stream in a handout format, so you can go through them there. Should also be fine.
Okay, then maybe we also want to give you some hints. Yeah, and probably it's something that you expect, but nevertheless, we want to mention them here. So this course is really a foundation for most programming and coding lectures that will be at some points in your studies. So it's really important that you take this course serious. Yeah, and it's not enough to just finish the assignments and get through the course in some way. It would be really important that you take it serious and do everything as good as you can, because everything you learn now, it's an advantage for you in the next semesters. And it's really, you really need everything that we teach here. So you really need to know everything and you need to apply everything. I mean, that's like some hint that's very obvious and everyone tells you, but it's really important that you learn along and you start early with the tasks. Yeah. So if you miss some lectures, then try to catch up as soon as possible, because otherwise you will lose track and you will not be able to get along again. And also with the tasks, the assignments, they are challenging. They are not super hard. They're all doable. But if you start 2 days before the submission, then probably it's too late. So you really have some time frame, and please use the time frame and start as early as possible. In the worst case, you finish the week earlier, right? And, okay, but if it's necessary, then you need those 2 weeks, and then you're able to finish it.
There were some questions in the chat, especially what's the difference between the assignments and the homeworks. The homeworks won't be any programming. The assignments will be programming tasks. The homework will just be something to do. It's probably not programming. And also where to submit the assignments, we'll get to that later in the stream. You will learn this here. And you have no access to the homework yet. We'll also release the homework at the end of the stream. Then you can have a look at it. And we'll also probably have a look at the homework together.
Yeah, we don't want you to read the homework description now. We want you to listen to us. I think you have a fourth hint, no? Yeah, and this is very, very obvious. Practice, practice, practice. And you should really do that. Maybe if you feel that you have some difficulties, then also practice more than just doing the tasks. Maybe, I'm not sure whether it was mentioned in the lecture, but there are also some additional exercises that we offer where you can practice. We can maybe show you that on the course website at some point. Okay, I think this was the organizational part, and now we come to some more interesting things, probably.
I'll start with the content. So first, Linux. Linux is an operating system, or more kernel, but you will learn about this later. It's open source, and we'll use it in this course because it's easier for you to develop in this operating system. And we also, our test system, which will be testing your assignments, will run on Linux. So if you use our virtual machine, which will Michi talk about soon, you can be sure that everything that's tested on your machine will be the same when we test it for the assignment. To specifics we'll get later.
There's one question, so which version of Linux?
I think you will answer that.
So I should answer that. Yeah. Okay, yeah. VM or virtual machine, what is that? I mean, probably most of you have a Windows PC laptop, maybe Mac, but probably most of you don't have a Linux version. And now with a virtual machine, we provide you an option that you can run Linux on your, for example, Windows machine. Okay, so maybe we'll show you that immediately.
So maybe let's
maybe stick to the slides and continue with that. That's a good
just
idea.
because I saw some questions about that. Because like which version of Linux, etc. So if you use our virtual machine, you can be sure that's the same setup as we use, but you can of course use other things such as the Windows subsystem for Linux or dual boot Linux, or maybe you have a custom virtual machine. You can probably you can also code on Windows if you like to, but then you can test your solution. So, but if you use anything other than our virtual machine, there are no guarantees that the test cases are the same when you test them offline.
So that basically means if you use some of these methods and your program is working there, it does not necessarily work on our machines, on our test system.
And there is a virtual machine for M1 and M2 Max. But it's also not guaranteed that it's exactly the same as our test system, because it's tested on x86, but it should be very similar. So yes, it should be on a teach center.
Okay, so maybe we have then a look on our virtual machine, and you already mentioned the teach center, so we might have a look there first. So this is the teach center. I don't know if you've seen it today already. And here in the general section, you can find 2 download links for the virtual machine. The first one is our virtual machine that we really use also for our test system, which runs only on x86. And there is also a second link to download the virtual machine for macOS if you're using this the ARM setup with an M1 or M2 chip. So basically what you have to do here, you have to download this virtual machine. I think it's, I don't know, 2 or 3 gigabytes, so it's maybe the download needs a bit longer. Okay, once you have downloaded this, you need one additional thing to run the virtual machine, and we will only discuss it for the ordinary case. For this one, we have a description provided.
We also have a description for the ordinary case. Everything is on the course website how you do it, but we just want to show it here.
Yeah. Should we also show it on the course website?
Yeah,
I think it would be a good thing.
Okay.
So we have linked everything here in the practical setup your device. Yeah, you can find here a detailed description on how to do it. Okay, but assume we have downloaded our virtual machine, then you need an additional program, which is this VirtualBox. You just Google for VirtualBox and you download the version that fits your operating system. You install it, and then if you open it, this looks something like that. And then you can import a file, and you import the file that you downloaded from our Teach Center, which includes the virtual machine. Okay, we do not show this here because it would take too long. And then you have here listed our virtual machine, and you can already see that our one is running. So just double click on it and it starts. And if it starts, then it looks like this. So it looks a bit like, I don't know, an ordinary operating system, as you know, like Windows or something. And within this virtual machine, you now really have a Linux environment where you can work in, and that's it basically for the virtual machine part. Are there questions?
I don't think I saw any which we didn't answer. So
okay.
I think we are fine.
Okay, then we continue with the slides.
Okay, so let's talk about the shell, which you will be using to do your first homework in. It's pretty important you know the basics of how to use it, because you will probably also need it when doing your assignments.
Maybe we do it very spontaneously. Can you open the shell now in the virtual machine?
So just you have an idea of how it looks. Here we have the terminal. And at first, it's just okay. Can you yes? At first, you just see you have text input here where you can type, and so basically the shell is just a program that executes other programs, and yeah, and each program you can specify arguments, and a program also has inputs and outputs. And what this exactly means we'll come to later, but yeah, just to give you a quick overview.
Okay, and then we go to the navigation setting section. So basically we want to show you now commands that you can execute in this shell or in the terminal that we opened. And we will now give you an overview over some important ones, and then we will also demonstrate them with an example. So don't be afraid if this is a lot of things that you see. We will show you them in the virtual machine. So basically, if we switch back here to the virtual machine, you can already see that we're in some directory now. And with the commands, pvd, we can show the current directory. So this is basically if you have a folder open in like a Windows setup, you visibly can see where you are, but with pvd in the shell, you can also make this visible.
And a command is basically a program. And in the shell, the first thing you enter, it's separated by spaces, is the program you want to execute. And pwt is basically the program that displays you, so the output of that program is the current directory.
Then, which you already also know from Windows, if you open a folder, then you can see all the files and all the subdirectories that are contained in the folder. And also for this, we have a command which is ls, like list, and then you can optionally add this path parameter, which folder you want to show, or if you just type ls, you can see the content of the current folder you are in. So
exactly.
Yeah.
On the shell, if you put a space after the command name, you can type in the arguments, which is different from the input of the program. And this ls program has the argument, a path it takes, and then it displays the contents of that path.
But it's optional.
It's optional, yes.
And one more thing regarding navigation, of course, if you remember back to Windows, you can double click on a folder to go into the subdirectory. And also for this, we have a command here, which is cd, so change directory. And here you necessarily have to input a path. So if you're in a folder, we would say cd and then some subfolder, then would switch to that subfolder. But this path can also be something longer, so you can navigate through your file system here. Okay, do we have any questions right now?
I don't think so.
Okay, then we continue with some operations.
Okay, so don't worry if you didn't get everything yet. We'll have a demonstration soon. But first, I want to go over some additional programs you can use just so that we can make a bit of a better demonstration. So first, make dir creates a directory with the specified name or path you provide as the first argument. Then rm removes a file. There you should just specify a file, and then it deletes it. And touch updates or creates a file. So if you write touch and then a file name and it doesn't exist yet, it creates this file, but if the file already exists, it just updates like the metadata of that file, so when it was last accessed, for example. Then we also have copy, where you specify a source file and a destination file, and then it copies that file from the source to the destination. Similar, we have move, which then doesn't copy it but moves it. So yes, so it's fairly straightforward, but let's start with a demonstration of everything.
So maybe we close the terminal again, and we show you some other way to open it. So we are now on the desktop here, and we can also right click and open a terminal here. And now you see that we are directly on the desktop. So I maybe make it, or you're already doing it for me. I do it now. Yeah, okay. So we increase the size for you. And yeah, now we can demonstrate the commands that we've seen. So with pbd, we see directly, okay, where we are. So we see the path to the current, to the working directory. And this is like home, student, and desktop. So this is, I think, no surprise. And then, as I also discussed with ls, we can list what are the files contained. And yeah, so we have here some folder, we have here some text file, and we have some other things here, like the link to Firefox. And to this ls command, we can also add some arguments. So we can write here ls minus l, for example. And then we see this in some more advanced view. So we again see all our files. And then we see some additional information. So we probably will not go in detail what this means. We see who created the file. So this is student. We can see the size and the date where it was created. So for example, this passport file was created on September 27, 2022, so last year. And also this folder was created last year. So we can really see the input. And I mean, I can show this now if you want to see that as well. If we go to desktop, I mean, then this would be like how you know it, and this is how it looks in the terminal. Yeah, so this is basically the same thing. Okay, now maybe we can do something more interesting.
Okay, so now, up until now, we have now only observed where we are and what we are working with. So let's do something. Let's use a program we discussed before and maybe try out to make the program, and let's create a folder. I don't know. Let's call it student and press enter. And now you see here on the left in the file manager, it already, you see that it's now created a folder. We can verify that if we type in ls, and we see here now, where is it here? We have created the student directory. As most other programs, Make also have some arguments. For example, we can do -p, which lets us create multiple directories at once if we specify a path, for example. If we type in student and then no test, and then we create a directory in the test2, it says, okay, we have an error. And basically most of the time in the shell, if you don't get any output, everything worked fine. And if you get any output, there could be an error. And we see here, there's no such file or directory student test, because test and test2 doesn't exist yet. But if you want to create both, for example, there's the -p argument. Now there's no output, and if we look in the student directory, we see there's a test directory, and if you look in the test directory, you see there's the test2 directory. So now we created multiple directories at once.
So basically the problem first was that in student, the test folder did not exist, so it could not create test2 in test because test did not exist. And now with this -p option, we can really create the test folder in student and the test2 folder in student test.
Yes.
Okay. So we can also have a look on another command. If we now want to navigate, we can use this change directory command, and we go into the student folder, for example. And then we can again have a look here with ls again, what is contained in the folder. And now we see, okay, here is this test contained. It's the same as we have seen before. And maybe we can do also something there.
Exactly. For example, now we talked about the touch command before. So if let's go, we already missed it. So let's create a file, something that doesn't exist. Let's call it txt, and no output, so it probably worked. Let's check. And now we see we have a file here that's called test.txt, and it has 0 bytes. So yeah, because it's empty, we just created a file. It doesn't have any contents yet.
Okay.
Yes.
Yeah.
So let's just demonstrate some last commands as well. Don't worry if you can't follow everything. You also don't have to know them by heart. That's what the homework is for. So you can practice them on your own. You need to do those things yourself, and then you can maybe go back to the stream or check the handout and yeah, try this on your own. So let's try maybe first the copy commands. We first specify a source and then a destination. And now this file is copied. Now we have 2 of them. Maybe we can also
switch into
here.
the folder. Yeah.
Now we see we have test and test2. So now let's check out the move command. The move command is not just for moving files, but obviously you can also rename files with them, because now if I move test to test3, we see that we have renamed the file. We can also move it to another directory. If we take test3 now, we can move it into the test directory. And now it's here. Wow.
Okay, so basically we can do all those kind of things that we would also do in the user interface with drag and drop, for example, but in the terminal.
Exactly.
And one last thing that we also want to show you. Now we are in this student folder, and how can we go back to the desktop? So we also need cd again, change directory, and how to go back. This is just with 2 dots, and with 2 dots we can always go back 1 folder in the path. And as you can see, now we are again in the desktop.
Yeah, there are some things. We also have them on the slides somewhere. Yeah, about paths. So as we saw here, dot is the directory from your current position 1 up in the hierarchy, and dot refers to the current directory. So if you do ls dot, we get the current directory. And now if we go into student, okay, we're in student, we can do ls dot dot, and we have again the desktop, because 2 dots refer to the directory 1 step higher up the hierarchy. Exactly. And then we have here the root directory and the user directory, but you do not have to concern yourself too much about this.
Maybe one thing, because I see it already in the chat. Such commands are very nice, but you should be a bit careful if you execute commands that you do not know. So there are some commands in the chat that you maybe should not execute on your machine, because maybe something bad can happen. So only really execute commands where you know what's happening, and that's why we also give you some introduction to the easy commands that we probably need every time we work in our environment. Okay, then we continue. So output, there are also 2 commands that we want to discuss. So there is this echo command where we give an argument where the argument is just repeated. This means, I can demonstrate it probably very quickly. If we have echo here and I write ABC, then my terminal writes ABC. And there is also another command that can now display the content of a file. So if we have cat and write the file name, then the content of the file is printed to the terminal. So echo was just for an input, and cat is really you specify a file name, and then the content of the file name is going to be displayed. And we will need this later on. Yeah? Okay, then maybe we're going to go 1 slide further. There is also a manual for all the commands. You just type in man and then some argument, and I think we have some example. Yes, so man ls would give you the documentation of this list directory command, and there is some description here what it does, and then there is also a bunch of arguments that you can add. And maybe we have to look on this L, where we said that we used this already, but it's listed in a better way than just using ls. Yeah, so for each command you can read through the manual, and you can do this in your command line. You just type man ls, or you can also Google for it and you find the description somewhere in your browser. Okay.
Okay, so let's now talk about what a process is. So a process is practically a running program, and when we type a program name into the shell, it executes this program, and this executing program is then a process. And we talked about input and output, and so what is this? Standard out, or std out, is the output most of the time of a process. And if you execute a program in the shell, then this output is displayed in the terminal. For example, the echo command Michi showed before then takes its arguments and then puts it into std out, and this is then displayed in the terminal. There's also std in, and this is not to be confused with the arguments of a program. So echo takes the arguments and puts it into std out, and for example cat, if you don't specify a file, takes the contents of std in and puts them to std out. Yeah, we can demonstrate that.
Yeah.
Yeah, okay, let's demonstrate that. So as we had before, echo abc, we have the argument, it writes it.
So maybe you can highlight the argument.
Exactly, here we specify an argument to this program, and then the program echo writes it to its output. And for example, cat can now display files, but if we don't specify a file, I think if you look at the manual, we see with no file, or when file is dash, read standard input. So if we just enter cat, nothing happens, because if we don't have a standard input for a program, the shell will just prompt us, the user, to provide the standard input. So for example, we can type ABC, and then we see cat just wrote what we entered back into std out, and now it's practically displayed twice, because the first time we entered it and the second time the program gave it back to us.
So the first line is the standard in, and the second line is the standard out.
Because you can see now I can write stuff, I can read it again, and as soon as I hit enter, it's sent to the program, and the program prints it again.
Okay, so all of those who say that's way too fast, yeah, we know that we have to cover a lot. And there is always the option to rewatch the stream, and maybe you can try everything. Once you've set up everything, you can try everything on your own, and you will also be confronted with that in the first homework and also in the first coding sessions.
Yeah, as Alex said, you don't learn much by just listening to us, but you will need to try this stuff out yourself and do this by yourself to really learn what you can do. Okay, now redirecting input-output of a program. So if we don't specify the input for a program or want the output displayed, we can redirect it. For example, with this bigger than sign, we can write the output of a program to a file, and with this smaller than sign, we can send the contents of a file to the input of a program. I think I should just demonstrate that.
Show those two.
So, for example, let's. Okay, we are a student. We have echo test. Echo now writes this to the output of the program, to std out, but we can specify How can I write the Wicked sign?
Want to do that, right?
Now we can send this to a file, and let's send it to test.txt. And if this file doesn't exist, as it does here, it gets created. So we see here we have test.txt, and now we can show cat.
What? But wait a second. What should be now the content of the file test.txt? So maybe to be a bit more interactive now with the chat.
Yeah, maybe I use the word test too often. It gets confusing now.
Maybe, yeah.
Yeah, it should be test. So we can do cat. Oops.
Test.txt.
Yeah. The test is the directory. So, and we see the content it says. Maybe let's do it. If we do something different, maybe now ABCDEF. Can you do the singular again?
Okay, yeah.
And then write test.txt. We can see that it has overwritten the contents of this file.
And now maybe to catch everyone back, maybe you can just open the file in a regular way.
Yeah.
We also see it here, yeah, in the mouse pad in the editor here. We really have the content in the file.
Yeah, and you see here, I also have two of those file symbols here, and this is basically the same. It's just I don't know.
You need some new word, yeah. You need my help again.
Can you do it?
You need two of them right now.
Okay, so, and if you do those 2 times, it will just append this to the file with a line break. So this is also, yeah. And then there's this third thing, which can be a bit intimidating, which is pipe. So now we have seen how we can send the output of programs to files. And okay, maybe I also show you how you can send the programs, files to the input of programs. For example, we have seen that cat just gives us back everything we send to its input. And we have also seen that cat can display the contents of a file if we specify to it. But now, can you do the other symbol? Yeah. Now we can also send the test.txt file to input of cat. Basically what we did here. And we see that it does the exact same thing as here. But instead of providing it as an argument, we send the file to the input of cat.
Okay.
Yeah, now to the...
Should we discuss the pipe?
Yeah, maybe not.
Okay.
Maybe that's an exercise for you if you're really interested in that for the pipe. It's not that bad. It just sends the output of one program into the input of another program, but it can be a bit complex.
Yeah.
Exactly. Echo overrides the file and cat reads the file, or the input if you don't provide a file.
Yeah, I think we'll leave out the pipe for now, and we also leave out the next slide with wildcards. But we'll just give you a short overview over some more commands that could be interesting for you, maybe.
Exactly. Also, maybe this could be a hint for the homework, because the homework, it states that you have to present a command in the homework, and it states that you can't use any commands that we presented in the stream, but except these commands, you can use these. So this is maybe a hint if you feel stuck or something in the homework and you don't know which command you should document, you can pick any of these.
Yeah, and all of them are useful, but a bit more advanced than what we've discussed now. But this is just for further reading and for you. Okay, so this was our section about Linux commands. And now we continue a bit.
Just some questions.
Yeah, okay, maybe we have some questions,
because pipe is like a filter, I think. This is not true. Pipe is really it just takes the output of one program and puts it into the input of the other program. I don't know, should I demonstrate it very quick or do we have time? Okay.
Probably not.
Okay, we probably should. Then let's continue to Git.
Yeah. Okay, so this was an overview on working on Linux, how to navigate through the folders, how to create files, how to create directories, and so on. And now we want to discuss another tool which is called Git, and also GitLab, which is how should I say this? It's a framework built around Git, maybe. Yeah, an implementation of Git. And we will use Git you will use Git to submit the assignments. So it's not that relevant for the submission of homework 1, but you will have to work with Git to submit your assignments. And now, what is Git? Git is a version control system. What does this mean? When we provided our homework, or Julia provided the homework for you, we had the situation that Julia did the first draft of the homework and then sent the tasks to Alex and David, and they did some correction, and then Julia reworked it, they send it back, there are also some corrections again, and so on and so forth. So basically, we created 5 versions of the homework sheet, and now if we always, I don't know, store the old version, update to the new version, whatever, this might get a bit messy. So with Git, you really have a system where you can always update your current content, and where you also can keep track of all the versions in a very organized way. And this all happens in a repository. So just think about a repository as a folder where you work in, and in this folder you do some work, and afterwards you just collect everything that you did and you package it together and create a new version, and then you can start continuing with that version. And with this is this Git part, and with GitLab you also have a server where you can download and upload changes. So in addition to just packaging and getting new versions, you can really upload those versions, and they are also saved on the GitLab platform, so you don't have to worry if maybe something gets lost. We already said this, and this also helps to collaborate. So if 2 of you are working together, which you will not do in the course, but maybe in your studies some point, then it's easier to just everyone can update or do some work and upload the changes again, and it's in a very nice and organized manner. Okay. Now the thing here for Git is, maybe we show you the website first. So this is just gitlab.thugraz.at. And then this looks something like that.
After you logged in.
And you probably do not see that many repositories. I hope that I'm not David. I'm David now. Okay. Doesn't matter. And now we want to set it up that this GitLab, this website, more or less in the browser, that you can work with that and on your virtual machine.
Basically, if you want to upload your changes, GitLab needs to know if it's really you that uploads these changes, and not that, I don't know, some other student uploads stuff for you. So we need to set up something on your machine so that so you can authenticate with GitLab.
Okay, yeah, exactly. And that's what we want to do now. I go to the slides and then we discuss what this is. So this is an SSH key, and we just need to exchange a key pair. So my machine needs one key, the private key, and this GitLab, the website here, we have to upload here the public key. And once we've done this, we can easily, I can easily upload changes and download changes. There are also some other options to do it, but that's a bit more complicated then, because you always have to authenticate. So we want to really create this SSH key pair and set up the communication with the server. And for this, we, not very surprisingly, need a command, which is this SSH key generation command. And we'll just copy it now. And we go back to our VM, so we close everything again. So we're back at the start, we open the terminal on the desktop, and I will just enter now the command here. And by the way, if you want to copy or enter something in the terminal, it's not enough to press Ctrl+C or Ctrl+V, but you also have to press Shift. So Ctrl, Shift, and V was now the way I copied it into the terminal.
Yeah. You don't have to understand this command now, just copy it.
We just
execute it.
Yeah.
This is the command you can execute without knowing how it works.
That's the only command. Okay, so this says, okay, we generate a public-private RSA key pair. Okay, we don't enter here anything. Okay, we already created one at some earlier point, so we override it. Then passphrase, we don't want to have a passphrase here. We just put enter everywhere. And now it says that there has been added this key pair, and we can find it in home student SSH ID RSA and ID RSA.
And very important, don't show anyone your ID_RSA file. With this file, everyone can authenticate for you. So just the pub file is safe because that's just the public key. Public, everyone can know that key, but this is the private key. Please don't show this key to anyone.
Okay, then we do what we have to do here now. We navigate to the public key, so which is located in home student.ssh. And now we have again ls-l. And now we see here this ID RSA pub. And now how can we display it in the terminal? We already learned it. This was this cat command because we open a file with ID RSA. Cat ID RSA pub. And this is then the key that was generated. And then I just grab it here. And now again, Control Shift and C to copy it. And now I go to GitLab. I go to my account. Then I have here some edit profile. And then on the left side, I can find SSH keys. And when I go on SSH keys, okay, there are some edits. Then I want to add a new key. I paste what I've copied here from before, and I can add the key. And now the key is added, and now from this moment on, I can really communicate with the GitLab server and can download and upload my changes.
Just to reiterate, this is just a public key. We didn't show our private key. So right now, if you knew the private key we just generated, you could theoretically access all repositories Michi has access to, but which we just pasted in here was just a public key, and you can't do anything with that.
Okay, so the communication is now established, and now what can we do with that? Maybe you can show us a bit in this direction.
Okay, now we can clone the repository. So first, let's create one. For that, we click here on New Project, create blank project, and then we can give it a name. Let's call it, so we don't have any other repository with that name by accident. Let's leave the visibility private, so just we see repository.
Yeah, and can you maybe choose my namespace here from Michgut somewhere? Yeah.
Okay, perfect. And now let's create a project. Okay, and now here yeah, you see we have the repository, we have an overview, some of the files that are in here. Here's already GitLab already created us a README file which has some infos in it to how cloning this repository might work. We don't need that. We just need here this clone with SSH because we just set up our SSH key. We copy that, go back to the terminal, and now
maybe you go back to the desktop.
yes, I don't know, something useful. If you just type in change directory without any arguments, you go to your home directory. Now we can switch to the desktop and let's type in git clone and then the name of the repository. Yeah, so now we see here it's downloaded, and yeah, here we already see the repo. And
so what is in the repository exactly now?
okay, in this repository is the README file we already saw online, the GitLab created.
So this was the same thing that we saw on the
Exactly.
GitLab, yeah?
And we have this .git directory, which you don't need to look into. It's just some data Git needs. It stores there maybe our GitLab server and the URL and stuff like that. So it knows if you execute any commands in that directory.
But we shouldn't touch it, right?
Yeah, we shouldn't touch it. Yeah.
Okay, now so we change to the test repo now, yeah? So we're inside the repository.
Exactly. Now let's continue with the config. This is important because it's necessary for the assignment, so we know who worked on this project. We can still see the GitLab user that commented, but it's just easier for us, and it is requirement for the assignments. If you don't do it, you will get a deduction. So let's let's just copy that. Okay, so now we have here git config. We specify that it's global so that it works for all the repositories you clone, and we set the email. So maybe just I don't know, student. So please, if you do that, put in your real email address, and also with that we can set our name. Let's just write test student, and now we can verify that it worked. If we just write git config and then maybe user.name, we can see now that we set our name correctly. Exactly. So now if you upload changes to the repository, your name and your email address will be displayed with those changes.
Yeah, and again, to mention this, it need to be really your name and your Theograd's email address. Otherwise, you will get some point deduction on the assignments because we really want to see that you did the work.
Yeah. You need to enter the public key into GitLab Online. You don't need to touch the private key. Just don't open it, don't touch it. Just take the public key and enter it in GitLab.
Okay. So basically we had this repository online, we cloned it, that we have a copy of it on our machine. Now we set up the config, and now we also want to see how to modify parts of the repository and upload it to GitLab. So there are just 3 commands that you have to remember. This git status just gives an overview of the repository, what happened there, and then there are 3 commands to upload changes, which is git add, git commit, and git push. So these are probably the 3 most important commands that you will use most often in our course and also in future courses. And just maybe we demonstrate how this works. So maybe you can go to the virtual machine. So we are now in our test repo. So let's have a look on it again. So we have this README in there and the .git folder, and then we maybe create a new file. So do you have a better name than test? I write utop.txt. We can verify that it's contained. Yeah, so the readme and the utop.txt is contained now. And now with git status, we can show what happened there, and we can really see we have an untracked file, which is marked in red here with yt.txt. So this is a change that happened because the file was not there previously, and now we created it. And now we can use this command git add and specify this utop.txt. And now this file is added to the changes that we want to commit. So what does this mean? Maybe imagine you are at school and you did your math homework, and you wrote it on some sheets of paper, and in the end you want to select which sheets of paper you want to bring to the teacher and which you do not want to bring to the teacher. And with git add you basically select those sheets that you want to submit and bring to school. Okay, if we now have a look on git status again, we see here changes to be committed. There is this new file, yt.txt. And now we execute the next command, git commit. And this command takes this argument, as we learned, -m, where we add a message to it. And the message usually contains some information, what were the changes. So, for example, added new file, or maybe, I don't know, implemented this feature, implemented this part of the code. But now we just added this new file. And we execute it, and now this was committed. What does this mean? So we provided the homework sheets, and now maybe we put them into, I don't know, in some folder that we really want to give to the teacher. So we put them together and give it a title, basically, with the message. So if we have a look on git status now, there is nothing to commit. Everything looks really nice. However, if we go to the GitLab repository online,
no, we have it open here.
Yeah, maybe even if we reload, there is still this readme. So our youtube.txt did not upload yet. And this is the last command, this git push. If we execute this command, then we really push it to the server, or we bring our submission, our math homework to the teacher. And then this youtube.txt is listed here. And you can also see on the top here that the test student submitted this commit, and therefore it's important that really your name is there, that we know that you did the work.
So to reiterate, with add specify which files we changed. Then with commit we gave them, basically we said what we did, we specified a message, and then with push we then actually push those changes to the GitLab server. So now they're online.
Yeah, and that's basically it. Yeah?
Yes. And it's fine if your GitLab is empty, you don't have any repositories.
Yeah, it's nice to have 0 repositories instead of having 2,000 repositories, because you have so many students that have their assignments. Okay, summary.
Yeah, and yes, to sum up, so we talked a bit about the organization of this course. Then we gave an introduction to Linux. I know this was much, especially for such a short time, but this is important. So maybe it would be quite useful if you look over these commands on your own and try to do the homework on your own. So yes. And then we have the introduction to Git, where we show you how to clone a repository and how to commit changes to it, and also how to create one. But you will also have to do this again in the homework. So
yeah.
Yeah.
So basically the homework will be some repetition of what you did today. And then we also continue to the homework. I know it's already 1 minute after 6, but we're done very shortly. So homework 1. Today is the presentation, so we'll be very short on the presentation, but nevertheless we will open it. The submission will be in 2 weeks' time on Wednesday in the evening. and you should submit a PDF report. And everything regarding the homework will be provided in the Teach Center. And yeah, maybe I go to the Teach Center directly. You can't see it, but now I will do this live in the stream that you can see the homework, because we already provided here. And now from why can't you see it?
Maybe display.
Do I have to? You have to put display here. Yeah. And from now on, you can really see the homework here. And you can also see again where it started, when the deadline is, so on the 18th of October in the evening. And here in this Teach Center activity, you also submit it. And here you can download the homework. And maybe you want to explain it, or do you want to go to the slides first?
What do we have on the slides?
Yeah.
Okay. So in the homework one, it's just about the command line interface, about the terminal, about the shell we just talked about, and you will have to execute some Linux commands and also some Git commands, so you get a feel for it. Okay. So I put a lot of effort into this homework to really explain everything. So I hope everything is covered, but if there are any questions, you can always ask them on the Teach Center. So first, I have this introduction where it says everything you have to do. So you have to create a report in any program you like, but you have to hand it in as a PDF file. And you have to document everything you do in the shell. So maybe take a screenshot of the commands or copy the output and which command you typed in. So this is completely up to you, but you have to document each command you entered.
No, this is really important.
This is important because otherwise you won't get any points. You need to document the commands you entered.
And what are the commands about then? And the tasks about?
So first, this is the only subtask where you don't have to use the command line. Like we did just before, create a repository and copy your SSH URL. Then you need to clone it, configure your name and email, check that it worked.
So basically exactly what they did in the stream.
Then you need to create a directory, create an empty file, check the status of Git, then verify. You have to check the status of Git and write it to the file, and then you need to verify the contents of the file, and then you have to commit and push those changes. And maybe the most interesting one, the last section, is you have to present or maybe describe in your report a command of your own choice. With a description and maybe describe some arguments. So you have to describe some arguments of the command. And you can't use any commands we presented in the stream unless those where we told you can use them. So in the further reading section.
So this was the homework part?
This was the homework.
It was maybe a bit fast, but of course you should read through the homework and then you can ask.
Everything I just said should be in the homework PDF and it's described there.
But it's nothing unexpected, I would say. It's everything what we did today in the stream. And maybe we move now to our last part of today's practicals. And we will always do this after the stream. So we would say that there is an official part until, for 1 hour. And then you have the option to ask us questions on Menti. And it should be already possible to ask questions on Menti. You have the link again in the YouTube description. And the advantages over the YouTube chat now that we can really display your question on the screen. And we try to answer all of them. But of course, we do this now in addition to the usual lecture times. So it's like a voluntary attendance, but this is basically always the case. Otherwise, are there questions in the chat that we...
I don't think so. Exactly. If you type in git clone and you will be asked for, if you are asked for username and password, if you type in git clone, then you copied the wrong link in the repository. You have to choose the SSH link and not the HTTPS link. So you need this one so you can clone.
Because we set up the SSH
Yes.
key and then we have to use it, of course.
I mean, it shouldn't be about like very simple, too short and about very simple command. You should at least describe some functionality of the command and also some arguments that the command has.
Yeah. Okay, so maybe we continue with the questions on Menti. You already had the first one. I'm sorry, I thought it was one of the YouTube chat. So is the virtual machine necessary since all of the commands can be done in the Visual Studio Code terminal?
The Visual Studio Code terminal uses the shell that's built into your operating system. So if you're using Windows and you open the Visual Studio Code terminal, if you didn't configure Windows subsystem for Linux, it's probably the Windows command line, which has different commands than from what we just showed you. So then you maybe should consider using the virtual machine or use any of the alternatives we described. For the homework, just if you have macOS should also be fine because you can enter the same commands there and they should work.
So basically just all Windows users are not allowed to use Windows, but everything else is more or less fine. Okay, die Zeiten im TU-Kalender stimmen nicht mit den Streamzeiten überein, betrifft nur die KU. I think that we had a little mess with the lecture times, but we will have a look on it and update it that it's correct starting from the next lecture.
Darf man. So if you have an ARM Mac, so an M1 or M2 Mac, there is a virtual machine on the Teach Center for you. So if you go back, maybe no. So here is the virtual machine for macOS, ARM and M1, M2 devices. You don't use Oracle VirtualBox. Then you have to use another program. You can check that in the course description.
You are already. Here it
is. Yeah. Yes. So it's pretty simple, but you need a different program.
Okay, then we continue with the next question. It might be worth nothing that you have to enable Intel virtualization technology in the BIOS if you can't boot the VM, because I had to do it on both my PCs. We know that in general the virtual machine can be a bit tricky, so if you cannot run it, if you have any problems, then feel free to ask also on the Discord or use the question hours that we will offer starting in 2 weeks. But it can be a bit tricky. So also I have had a problem with my virtual machine when I did ESP 4 years ago. Ja, natürlich.
I mean, theoretically yes, but it would be good if you also explain I don't know why you chose the commando, or like just some like, I don't know, one sentence or so.
How do we find a command to describe for a homework if we haven't heard of it in the lecture yet? I mean, we offered this slide on further readings on the command, which we have somewhere here.
Exactly. You can pick one of those commands if you want to. Maybe, I don't know, look over them, what each of those commands do, and then maybe you can pick the one that you like the most and, I don't know, describe it.
Or you just Google for commands and
and you don't have to describe all arguments of the commands, maybe just a few basic ones, because they can get pretty difficult.
Yeah, if you think
Complex.
back at the manual of LS, you
Yeah.
don't have to describe like 30 arguments. When and how can we get in touch with our mentors for first questions? I honestly have to admit that I don't know it. Maybe David or Alex can answer it in the chat, please. Yeah, maybe
Yeah.
continue just. Yeah, so why does it need to be done via GitLab and not via Teach Center? And the reason is first that GitLab is way easier than Teach Center, also for us. And the second thing is that using Git is state of the art in computer science and in programming.
Everyone uses Git. You'll need to use it in other lectures as well, so you need to learn how to use it.
Yeah, so we already started early with that.
Yes.
Yeah.
Of
yeah.
course, but it will be a lot of work. So it's not easy to learn all of that. You need to practice.
Yeah, but if you practice, you really have good chances to get a good grade.
Yes.
I want to say that students who have no experience in programming before the course, I have the feeling that some of them really do better than students who have a lot of experience because they take it more serious and really follow the things that we tell them, follow our code quality constraints and so on. So even if you do not have any experience, you have really good chances that you perform very well in the course.
It should definitely be doable.
Yeah.
If you have just a normal Mac, then you can use the other virtual machine and just download Oracle VirtualBox, and that should work.
It's just for the ARM chips, the problem.
Mm-hmm. Yeah.
Yeah.
I mean, you need to just practice with every week, basically. So you follow the streams and do the homework and try really understanding everything that's presented on stream.
Yeah, but it's really doable. I mean, maybe we are very contrary because when you started studying, you really had a lot of experience in coding. And when I started studying, I had really no experience in coding. And now we're both sitting here and holding the lecture. So yeah, it's really doable, and you will manage to do it. You will manage to do the course, of course.
Why does the course mention that testing on micro machines is not? Yes, there can be difference between how the computer executes code, or between Linux versions, or between compiler versions. You will learn later what that is. So it's really difficult to have like the same environment on every machine, and if you have like a Mac with an ARM machine, it's especially difficult because it's a completely different architecture. But don't worry, when you upload your changes to GitLab on your assignment, you also see on GitLab how many test cases you pass. So, and this is then in our testing system. So even if you can test locally, if you push to GitLab, you see how many test cases you pass. And you can do that as often as you like. So you always know how many test cases do I pass in the testing environment that we use.
Mm-hmm. Yeah, okay, just continue here. I'm a mentor. How do I get in touch with my students? Then you have to ask your course team, I think, which is Alex and Daniel. Is there a fast lane for students that have already done OP1 but have to complete ESP? No.
I mean, you should be experienced enough to know what.
I mean, you don't have to watch the lectures, basically, yes. if you feel that experienced.
Yes.
So you just have to submit the assignments and do the homeworks and go to the free coding sessions.
No, that's completely up to you. You can design any way you like.
Mm-hmm. Yeah, basically, this is just the homework until 18th of October, and in 2 weeks also the coding session starts, where you can register probably start of next week. But of course, for the homework, you need to do all the setup, so there is some work, yeah.
Nicht ganz. Also die VO und KU ist immer auf YouTube und es gibt auch immer Aufzeichnungen. Coding-Sessions sind nicht freiwillig. Man bekommt Punkte dafür. Dann gibt die Question Hours und die sind freiwillig. Ja. Und da wird euch auch geholfen. In den Coding-Sessions wird euch natürlich auch geholfen, aber ihr müsst 3 Coding-Sessions besuchen, wenn ihr die Punkte für die Coding-Sessions wollt.
Ja, genau. Is VMware also allowed to work with?
As we said before, you can use any Linux setup you like. It's just that with our virtual machine, you'll probably have a better time getting the same test results as you see them online on GitLab.
Is there a Linux alternative of Windows users for documenting the commands of the first homework? Yeah, so basically we said either use our virtual machine or set up a Windows subsystem for Linux.
I don't know what Windows PSR is. But yeah, I don't know.
Okay, I didn't read it correctly.
Yeah.
I'm sorry, yeah. Yeah, today there is the TU Fest.
Yes, you get the slides, and also you get all content in a handout format we have on the slides.
Probably tomorrow.
Yes. The question now?
Yeah, probably something for David or Alex.
Oh, okay.
We continue.
It should also be on the slides then.
Yeah.
Yeah.
What sites, platforms do we need for this lecture, coding TO-Cards?
Most importantly, our course website, so coding.tocards.at, and the Discord for communication with your tutors.
Yeah, and you find everything on Notion.
Mm-hmm.
Yeah.
And the teacher center is just for handing in the homeworks and registering for
coding sessions.
Coding sessions because it's easier on there.
Ja, Coding Sessions starten in nächste Woche, noch nicht in 2 Wochen starten die Coding Sessions. Kommt dann noch.
I think it's Ubuntu.
Yeah, I think it's X Ubuntu in the virtual machine, but also Ubuntu is fine.
Mm-hmm. Any Linux distro is fine. You can see the private test cases on GitLab, how many you pass, but not what their content is, obviously, because they're private. But you don't need to worry about this now. You will learn everything about it when we hand out the first assignment.
Mm-hmm. So in 1 month. Okay.
Thank you.
Thanks.
Both
is fine?
Yeah, both is fine. You don't have to write extremely detailed description about everything you enter. Just make sure that every command you execute is in there. Maybe write a bit what you actually did with that command, and then give a description about the command that you chose. So describe a few arguments, maybe give a few examples. So it doesn't have to be that long.
Mhm. VM ist bei Mac sehr, sehr langsam. Wie fand Sie lernen kann, aber nicht testen. Was empfiehlt ihr? Wie eben gesagt, man kann dann auch auf GitLab testen. Dann ist wahrscheinlich halt besser, nicht die virtuelle Maschine zu verwenden.
Wenn die VM halt nicht funktioniert, vielleicht bist du auch auf einem M1 MacBook und verwendest die andere VM. Vielleicht funktioniert das schon, aber dann wird es emuliert und das könnte wirklich sehr langsam sein. Genau, man kann auf macOS auch gut einfach lokal ohne irgendwas programmieren, aber dann siehst du eben die Testcases nur online.
Mhm. This is off topic, but can we get any free licenses as TU students or there?
I don't know.
I think there is an option, so you find it somewhere in the TU for you probably.
Yeah, that's a bit unfortunate. I wish it were different, but we use a safe exam browser at the exam, and it's not available for Linux. But we do provide extra slots for people who just have a Linux system, so they can work on computers at the university.
Yeah. Okay.
Yeah.
You should store your repo in an appropriate folder. Yeah. And you should not execute any commands that you see in the internet.
Yeah.
I'll repeat this again.
Except on our course website.
Yeah.
Yes, you can. Thank you. Yes, you don't need to request anything on GitLab. You will get your repo when you need it, and you don't need it right now.
Ja, also ich meine, es ist generell so aufgebaut, eben, dass jetzt Design Your Own App quasi die Grundkonzepte vermittelt, die auch in C gültig sind und wir dann anschließend mit den C-Konzepten weitermachen. Also es macht natürlich Sinn, viel auch in Python zu machen und dann kann man auch mit C drauf anknüpfen.
Yeah, so in this example, git branch, it's like a subcommand. Git is the command, branch is an argument, and branch now tells the git command that it should execute what it should do with the arguments, the other arguments you provided. Whatever. Okay, so it's like a subcommand, but it's actually an argument to Git.
But it's allowed to be used because we said describe a Linux or a Git command, and that's what we mean with a Git
So you
command.
can describe Git branch as in your homework if you want to. Yes, I think so. Except for presenting a new command.
Yeah. We really recommend that you really do homework 1 and do the whole setup, because you will need the virtual machine or whatever Linux environment you want to use
for the assignment.
For everything. Yeah, so don't skip the first homework.
Oops. Can I go back like this?
I will search for the question.
Okay. Nein, müsst ihr nicht, nur irgendeine Unix-basierte Maschine, also entweder macOS oder irgendeine Linux-Distribution wahrscheinlich.
Okay, es war vorher nur die Frage für die Lehrveranstaltung Einführung in die Programmierung, also für die Elektrotechnikstudenten. Da brauchst du nicht angemeldet sein, es reicht, wenn du für Einführung in die strukturierte Programmierung angemeldet bist, Vorlesung und Übung, und danach geht das dann über das Dekanat, dass man sich das Einführung in die Programmierung angerechnet bekommt.
Yeah, you will get the repo, so the repository for the assignments when the first assignment starts.
And for the homework, you have to create one on your own.
Yes, like that's part of the homework, but you still have to submit the homework on the Teach Center.
Yeah. Yeah, that's really nice.
You can always learn more. I don't know what Windows PSR is.
Yeah, I didn't get the question right before, so I'm very sorry.
On the Teach Center, and it will be available next week.
Yeah.
For public test cases, yes. If you test them locally or on GitLab, you see why the test cases fail.
Why do we have to learn or use Linux?
So basically, that's also because you really need it, especially for lectures that follow this one. And it's not just because of these lectures. If you want to be a programmer, you will probably also need it in your work life.
Yeah, we answered this already. Both is fine.
Yes.
Yes. There will be question hours offered. Yes.
You can name it anything you want.
Yeah.
Because if you set it to private, only you can see a repository. No, because you don't have to document anything about the installation part.
Yeah, that's true.
Just the config stuff, and that you can just execute again.
Yeah, you can do it again. Yeah, no problem.
Yes, okay, I also saw that in the chat. I accidentally put the Mac virtual machine on the wrong keyboard layout. You would have to find the settings for the keyboard layout and change it to German, so you can use the keys like you're used to.
Yeah, so basically, if you're on Mac and don't have an M1 or M2, then you download the... it's meant for the homework.
Yeah, for the homework, if you don't want to use a virtual machine, just open the terminal on your Mac. The same commands work there.
Yeah.
Yeah,
we already answered this several times now.
Okay.
That's it for now. So maybe we switch back to us. Yeah, okay, so the last question, I think that's okay, we can leave this out now. Yeah, this was the first stream. So we, as you've seen, we did 1 hour where we did stuff with Linux and Git, and now we had this additional half an hour where I answered your questions, and that's the same way we'll do it also next week. Is there anything left that we need to mention, or are we done for today?
In the chat is the question, do you have to download Git and GitLab? No, GitLab is online, and if you use the virtual machine, you don't have to download Git. If you use another system, then yeah, you have to install Git.
Okay, I think that's it for now. Then we wish you a nice evening. I hope you have also some fun with the first homework. I mean, of course, it's some work to do, but I hope that's also fun for you to do it and to start your career into computer science. And yeah, we wish you a nice evening and see you next week.
See you next week. Bye.
Bye.